Okay, Lamai. Let's discuss the 2003 A-level question, which is actually appearing at the page number 25 of your tute. Right? This is the question number 2 at your page number 25. Right? See what they are saying. So they are saying solution B contains chromate and sulfate ions. The following procedure was employed to determine the concentrations of these ions. Right? Okay. See. So this is done to determine the concentrations of chromate and the sulfate ions. So goal is identified, right? You can take the chromate amount as X moles and sulfate amounts as Y moles then, right? Okay. So let the chromate amount is equal to X moles and the sulfate amount is equal to Y moles, right? In 25 cubic centimeters, right? So goal is identified, right? Okay, then let's come up with the first procedure. So 25 cubic centimeters of solution B was reacted with excess lead nitrate solution, right? So we are coming up with, right, excess lead nitrate solution added to 25 cubic centimeters of this S solution, right? So this contains these two ions, right? So the chromate ions as well as sulfate ions. We know with this one you have with X moles, with this one you have with Y moles, right? Excess lead nitrate is added, right? Lead nitrate is added, right? Then they are saying to completely precipitate chromate and sulfate ions. So we know here no use of the nitrate ions here. Nitrates never get precipitated, but lead 2 plus ions will precipitate with the chromates as well as the sulfates, right? So kind of a precipitation appears, right? And its mass is given. After drying, the mass is 0.929. That is given, right? So with this one, right, you can think of the lead chromate as well as lead sulfate, right? Because the chromates and sulfates will precipitate with lead ions, right? Okay. So first come up with the let's come up with the first chemical equation with this precipitation procedure, right? So we can write that two chemical equations there. So lead nitrate reacting with chromate ions as well as with sulfate ions, right? So lead nitrate reacting with the chromate ions, giving you, right? So I'll write it here, no? To preserve some space, right? Okay, let's write it like this. First, the lead nitrate reacting with the chromate ions. So it will produce the lead chromate like this. Lead chromate. The cation comes with the anion of the other species, right? Lead chromate. That is so precipitate. And the anion will release here 2 of NO3 minus ions, right? So that is the first equation. The second equation is lead nitrate reacting with the sulfates. Lead nitrate reacting with your sulfate ions. So that is lead sulfate is your precipitate, and the 2 of nitrate ions will release to the solution, right? So here you are with X moles, here you are with Y moles. So data point is provided as grams of the precipitate. This is your data point, and this is your data point, right? So we need to come up with a simultaneous equation for your data point, right? So we can write the simultaneous equation for the mass of the precipitate, right? So you can write for the mass of precipitate in grams, right? So if this is X moles, as these two guys are with 1:1 ratio, this is also X moles. If this is Y moles, this and these two guys are with 1:1 ratio, this is Y moles then, right? So we are looking for the mass of the precipitate, right? So let's come up with the molar weight of these guys to come up with the mass of these two guys, right? The summation is equal to this value, right? So for that, we need to come up with the molar weight of lead chromate as well as molar weight of lead sulfate. So lead chromate, right? Lead is 207, chromium is 52, 4 of oxygens, 16 into 4 is 64, right? 13, right? 1, so 323, no? Right? That's the value, no? Lead chromate 9, 13, yeah, 12, 1 and 200, 322. Right? What about the value for lead sulfate? So the value of lead is 207, sulfur 32, 4 of oxygens 64, 16 into 4, right? So 9, 13, 1, right? 303, no? 303. So we can come up with the first equation now. So that is this G mole minus 1 value into its number of moles will give you the mass of the lead chromate. G mole minus 1 value of the lead sulfate into moles of lead sulfate will give you the mass of lead sulfate, right? That summation is equal to the precipitation mass. That will provide you the precipitation, right? So we can write the first equation, right? 323x plus 303, right? Y is equal to 0.929 grams, right? That is your equation number 1. Done? No? That is about the equation number 1, right? Okay. Let's try to come up with the second simultaneous equation with the use of the second data point. Let's go to towards that, right? After this, they are saying the mass of the precipitate so obtained was after drying is this amount. That is done. Then they are saying the precipitate then treated with excess of DIL HCl. Precipitate then is treated with excess of DIL HCl. That is what they are saying, right? So precipitate is treated with excess of DIL HCl, right? So what will happen? The precipitate will dissolve if you are not with a strong acid anion there, right? So actually this precipitate contains lead chromate as well as lead sulfate, right? So when it comes to this one, it is not a strong acid anion, so that thing will dissolve. The thing will dissolve, and this is not the DIL acids, right? So we can write. So this is your precipitate, and this is your precipitate, right? It was with lead chromate and lead sulfate. Those are two guys precipitate. Being adding a dill acid, what will happen? Right? This thing will dissolve while this stands. Right? So as this guy is not coming from a strong acid, this thing will dissolve. So this dissolves, right? So after adding the acid, the solution becomes like this, right? Precipitate will remain, right? This is lead sulfate. Precipitate will remain while the chromate ions will come to the solution. The chromate ions will come to the solution, right? Pb2 plus ions and chromate ions will come to the solution, right? And remember, the medium is acidic. As you have added some H plus, right? Now this is how the system looks like after adding HCl, and excess of Ki is added. Then you have added some excess of Ki. Right? Ki, that means K plus and I minus is added. Then what will happen, Lama? Here what will happen? So with Ki, I minus always tends to get oxidized to I2. Right? There is no other way X minus form or the X2 form can appear with the halide ions, halides, right? Halogens, right? So this is kind of a oxidation, because this is -1 and this is 0, kind of a oxidation. So we are looking for only a reduction at the flask. So Pb2 plus can't get reduced, right? So Pb2 plus can't get reduced, right? So with the solution stuff, right, only chromate ions are able to get reduced. So the reaction is what? The reaction is acidic medium reaction of chromate reacting with the I minus to produce the I2, and in acidic medium chromates will reduce to Cr3 plus. The reaction there is the acidic medium reaction of what? Right? I'll write it here. Chromate ions, right, reacting with I minus ions, right, to produce Cr3 plus and I2. That is the reaction there, right? Okay, that is clear. This dog guys won't participate, right? The I minus is the one which will get oxidized. So you should think of a reduction at the flask. So reduction is possible only with the chromate ions here. Your Pb2 plus, you don't have a low oxygen state, then 2 plus, right? The lead ions, only the Pb2 plus is appearing in the solution, right? So chromates will reduce in an acidic medium to Cr3 plus, right? That is what we know, right? Okay. So after that, what they are saying? They are saying the liberated I2, the so produced I2, they are saying the so produced I2 is then reacted with sodium thiosulfate. Then reacted with sodium thiosulfate. That's what they are saying. They reacted with sodium thiosulfate, Na2H2O3. And the consumed amount is also given as 30 milliliters of 0.1 molar solution. So the sodium thiosulfate, I write it here, is sodium thiosulfate 0.1 molar, 30 cubic centimeters were consumed to totally react with I2 here, right? So the reaction there is the sodium thiosulfate I2 reaction. You should know that the reaction is 2 of sodium thiosulfate reacting with I2 to produce the 2 of NaI plus Na2S4O6, right? Okay, so these are two reactions. First we let's balance this stuff and then come up with a simultaneous equation for this data point. This is your second data point here, right? This is your second data point, no? So second data point. Okay, let's come up with first. Let's try to balance this one. So if you balance this one, it's like plus 6 appearing here, plus 3 appearing here, 3 electron difference. First of all, you need to multiply this thing with 2 to atomic balancing redox species, right? So minus 2 here, 0 here, right? 2 electron difference. Here the 3 electron difference. So this is 2 electron difference. This is 3 electron difference. So first of all, this should be multiplied by 2, as least common multiple is 6, right? This could be multiplied with 2, right? It's 2. And these things should be multiplied by 3, right? 3. That means 3 into 2 is 6. It's 3, right? Like that, no? Okay. So let's complete the balancing by adding H pluses and H2Os, right? So at this side, you have minus 4 and minus 10. At this side, plus 6, yes, this plus 6, no? As a charge. So 16 units of difference is there, right? 16 of difference. So you need to count with 16 H pluses at this side, right? And then 8 of H2Os, no? Okay, the two reactions are balanced. So this is your data point. This is your data point. The amount of sodium thiosulfate, that is your data point. So you have to bring those X moles, Y moles things towards here. The X moles, Y moles things towards here. You have to bring that, right? So what will happen? So here the chromate amount is X moles, right? Here the chromate amount is X moles, right? X moles, no? From X moles of chromate, X moles of lead chromate has been produced. So the chromate amount here is X moles. The chromate amount here is X moles. So here as well you have some X moles. Here as well you have some X moles of chromate, right? And the H plus. Right? X moles of chromate is there. So the chromate amount is X moles. Chromate amount is X moles here. From X moles of chromate, you will produce, right? You will produce X moles actually for 2 portions. You will produce 3/2 X moles of I2, right? No, X moles is for 2 portions, so we need such 3 portions. So per 1 portion, X moles divided by 2, such 3 portions, X mole 3/2 X moles, right? Okay, it's clear, because the I2 is the one which link the two equations, right? That is why I prefer the I2 here with X moles, right? So 3x/2 moles of I2 is produced. So this amount is that, the produced amount, 3x/2 moles from the chromates, right? So that amount is here, 3x/2. So that as I2 to thiosulfate is 1:2 ratio, the amount here is going to be 3x moles. 3x moles. Got the idea? Right? So 3x/2 I2 means twice that of thiosulfate should consume. So this thing into 2 is 3x moles. So now we can come up with the second simultaneous equation, which is for the moles of sodium thiosulfate. That is your second data point, right? So for moles of sodium thiosulfate, right? So that is going to be 3x, and on the other hand, that is this number, right? So Na2S2O3 moles is equal to 0.1 molar 30 cubic centimeters, right? That is equal to 3 into 10 minus 3, no? Right? That value is equal to 3x moles. That value is equal to 3x moles. So your 3x is equal to 3 into 10 minus 3, 0.001. Sorry, 0.003, no? So it's 3. So one can say 3 into 10 minus 3. That is your second equation. From this, you can write, let's solve for two equations, right? This one and this one, no? Those are two equations we are supposed to solve, right? Okay, let's solve for these two guys. I'll erase this one, right? We have 3x, no? Right? Okay, let's solve for two equations, right? From equation 2, right, x is equal to 1 into 10 minus 3, no? Okay, this divided by 3, no? So you can write that value here, right? X is equal to 1 into 2 minus 3. So from equation 1, applying this value here, we'll multiply this value with 1 into 2 minus 3. That means that is 0.323, that plus 3y is equal to 0.929. Then this comes here, then it is going to be 3y is equal to 0.606. That means y is equal to, that means y is equal to, you can take the y is equal to what? This divided by this value. So that is 0.002. So that is 2 into 10 to the power minus 3. Right? Those are two values for the x and y. Right? So ultimately, we can come up with the concentrations. No, they are looking for the concentrations. Yes. Now we can come up with the concentrations. So the two concentrations, let's come up with those. First for the chromates, right? So the concentration of chromate times is actually equal to what? Right? So your number of moles is 1 into 2 minus 3. The concentration is, sorry, the volume is 25 cubic centimeters. In 25 cubic centimeters, you had x moles, right? So 25, right? So the value for the chromate is actually 1 over 25. That means 4 over 100, 0.04. This is the concentration of chromate here in this solution, S solution, right? Sorry, solution B, right? So let's come up with the concentration of sulfates as well. The number of moles of sulfate is y moles. Y means this value, 2 into 10 to the power minus 3 moles. That was inside 25 cubic centimeters, right? 25, right? Okay. In decimeter cubes, we need to write. So the number is 25 over, so 2 over 25 means 8 over 100. So that is 0.08. Right? So those are the two values. Right? So that is how we are supposed to solve the 2003 question, which was actually the second question of your page number 25. Right? Let's complete stuff.